All right, here's our magnetism review. First question, how is the direction of a magnetic field defined? So here, the magnetic field, which we use a B for, points from north to south. That's how the magnetic field is defined. What is the unit that the magnetic field is measured in? It's measured in Tesla. So you use a big capital T for that. What kind of magnetic pole is the geographic north pole of the Earth? It is magnetic south. Oops, sorry. The north end of magnets point to it. That's what makes it magnetic south. Draw the magnetic field surrounding a bar magnet. So if we have a bar magnet, we need a bar. Have a north end. Oh, backwards, I guess. It's not. We have the north end. We have the south end, and the magnetic field around it goes from north to south in these nice little loops. Limited by space, obviously. Little loops, bigger loops, biggest loops, and then inside they point from south to north, because inside of magnet they're little bitty things. Draw the magnetic field between two bar magnets held so that the north pole of one faces the south pole of the other. So we'll make this a little bit smaller. Two little magnets here, and we'll go north, north, south, south, and then here our magnetic field points right here this way, and then it would kind of loop around like that. Be a little loop here, a little loop here, big loop, little loop, little loop, little loop, big loop. Can you tell where the magnetic field is strongest? In general, it's where the lines are closest together. And so in general, that's kind of that little spot there. A bar magnet's broken in half. Describe what happens to the magnetic poles. Draw the pieces showing the poles for each piece. You get two new magnets. Both with north and south poles. And so you take your magnet that you broke in half, that's a little break spot, and if you had north here and south here to begin with, you get a new north right here and a new south right there. And so you get two new magnets when you break it in half. And that's going to happen as you break any magnet in half all the way down to the little molecular level. What is an electromagnet or solenoid? It's a current carrying wire wrapped in loops to create a magnetic field. Draw a picture of an electromagnet and sketch its magnetic field. So let's say we have current going this way. We'll go out and in. As you can tell, my drawing is amazing. It's okay if your drawings aren't that good. There we go. there's an electromagnet, and if we look at the magnetic field through there, the magnetic field runs in this direction, straight through the magnet, and so the magnetic field would point this way and would be as if there were a north end here and a south end there. How can you increase the strength of the electromagnet? You can get more loops and you get more current. Those things would increase the strength of electromagnet. When does a charge experience a force due to a magnetic field? When the charge moves perpendicular to the field. And so the two important things here are that the charge is moving and that the charge is moving perpendicular to the field. If it's moving parallel to the field, it will not experience a force from the magnetic field. So we have to have some part of its movement be perpendicular to the field in order to experience a force. Describe how you find the direction of the force on a moving charge. Using your right hand, make a finger gun with your middle finger kind of out, perpendicular to your pointer finger. When you do that, your pointer finger is the velocity. Your middle finger is the direction of the magnetic field, and your thumb is the force. What path does a charge take in a magnetic field? It takes a circular path. The force is perpendicular to the velocity. So the magnetic force is a centripetal force. Describe the operation of an electric motor and draw a diagram. What do electric motors do in terms of energy? So for an electric motor, you have a current carrying wire. This is a really simple electric motor. You have current going this way, current going through, current coming around. And you put that current carrying wire in a magnetic field. And if that's the case, using your same right-hand rule, using a different right-hand rule, sorry, there's a force into the page here and a force out of the page here. That force causes a spin, and that's your motor. In terms of energy, electric energy is converted to mechanical energy. When is current induced in a loop of wire? Explain in terms of magnetic flux. It's induced when the flux through the loop increases or decreases. If there's a change in the flux, you're going to get an induced current. Flux is magnetic field times area. So if the magnetic field changes or if the area changes, you're going to get an induced current in the magnetic field. In order to calculate the induced current in the loop, the first thing you do is find the EMF. That's the change in the magnetic field or the area over the change in time, right? So it could be option A is the area times the change in the magnetic field over the change in time, or the magnetic field times the change in area over the change in time. It just depends on what's going on. But that's going to be your voltage. Your induced current is going to be that voltage divided by the resistance. And that's what you do. Describe the operation of an AC transformer. Draw a diagram. Why do we use AC current instead of DC current to transmit electricity? We'll talk about that. All right, so for our transformer, you have this block of metal. And on one side of the block of metal, you have a current carrying wire. But you get just a couple of loops of current carrying wire here. So not a lot, just a couple. And it runs off. The other side, what you get is a lot of loops of current carrying wire. So not just one loop, but a lot of loops current carrying wire. And so with all of those loops, we get DC current that goes back and forth. It creates a magnetic field that changes direction here, that creates a magnetic field that changes direction there, and what we get is an increase in voltage. So the AC transformer increases voltage. It leaves the power the same, but it increases voltage, which is good. High voltage allows for long distance transport of electricity. The reason high voltage allows for long distance transport of electricity is that high voltage, low current means lower power. We lose less when we have a high voltage. Those wires don't get as hot. And that's why we use AC. We can't transform DC current. We can't up the voltage in the same way. AC current we can. It's perfect for that. All right.